I show the first one, you'd be like, oh, that makes sense. Eat first. Okay. So, I see perpendicular to the y-axis, which to me that does two things. That tells me everything in my equation needs to be y. So I have to solve for x. And it tells me the little strip that I draw is going to be perpendicular to the y-axis, which means the distance between those. Like I'm just trying to see is it going to be right minus left or top minus left. When I draw the strip, I think it helps realize, okay, that's right minus left. That's x equals 1, so that's x equals 1 is actually in terms of y. Remember, in terms of y means solve for x. So that's fine. That one's not. So y equals e to the x. What's the opposite of raising e to the power? What's the opposite of e? What did you say? ln. So I'm going to take the natural log on both sides, and x would equal ln of y. That is x equals 1. That is x equals ln of y. So far, so good, Carter? Alright, so I'm going to integrate. Everything's got to be y values. So I'm looking like the lowest y value, which is 0, to the top y value, which is e. And then I'm going to integrate the area. So the area of all of the rectangles that are coming out, because remember these are rectangles like coming out at you. The height is 2 times the width. So I know the area is the height times the width. But the height is 2 times the width. So I can replace that, and then the area becomes 2 width times width. So my area is 2 width squared. That's dy, because we're in y's. And then in general, not specific to this problem, but in general, what's going to go in that slot? Right minus left. So I want this distance. So that is 1 minus ln of. What's that? Yeah. Oh. Yeah, because this isn't going to work. Yeah, good call. Carter, we're going to start over. Okay. First of all, if I gave you this question, I wouldn't, and you had an option. Sometimes they'll just say, like, find. You don't really have an option. Yeah, I didn't notice that. So we do have, this is the right hand side, but there's 2 left hand sides. So that's x equals 0. That's our x equals ln of y. Can you see how there's 2 things on the left? Because it like splits that way. So we're going to go from 0 to 1. The right minus left. So it's still 2w squared. And right minus left would just be 1 minus 0. And then from 1 to e, so like the rest of the way up, it'd be 1 minus e to the ln of y. 2 times w squared. So like that. My bad, I didn't even like check to see it. Does that make sense? Alright. 10, you said also? Any other questions on it? Alright, perpendicular to the x-axis. Here, each cross section is, we got a rectangle, but the height is like 10 times the width. So that's your w, that's 10w. And then the area of each little rectangle would be 10w squared. I'm going to integrate from, everything I put in here needs to be x values because we're perpendicular to the x. This is in terms of x already because it's solved for y. My x values of the shape are negative 1 and 1. The area is 10w squared. And then the width is top minus bottom, so it's this equation minus, that's just y equals 0. So it's going to be the square root of 1 minus x squared minus 0 squared, but the minus 0 doesn't need to be there. And I wouldn't be surprised if they wrote it like this. this. Because the square and the square root is just going to cancel. So I could see some people getting that and wondering if they're right or not. I don't know if that's going to happen, but either of those would work.
No, you were right the first time.
Oh, yeah. Okay. Do you have others? Do you have three or just two? Any others? Okay, cross section perpendicular to the y-axis. So I know, like right now, I can just kind of put my dy there if that helps. I know I'm going to be in terms of y. I can draw that perpendicular to the y-axis cross section. That helps me realize it's right minus left. But these are in terms of x, and I need to be in terms of y. So if I square both of these, I get y squared equals x. And if I multiply both sides by 3, I get 3y equals x. So this is x equals 3y. And this is x equals y squared. Cross sections are rectangles whose height is 6. So the area is the base times the height. The base is right minus left, so it's the 3y minus y squared. And the height, it's just 6. It's not like 6 times anything else, it's just 6. So every rectangle coming out has the same height, and they're all height of 6. So that's my area. And my job is to integrate that between the y values. So the lowest y value is 0 and the highest one is 3. And that's the base of a rectangle, and that's fine. Okay. Any others? Alright, perpendicular to the x-axis. I'm going to draw that in. That means I'm going to be in terms of x. I'm going to throw my dx there as a reminder. These are in terms of x because they're solved for y. That one's y equals 1, it's a horizontal line. That one's y equals sine of x. The rectangle whose height is 3 times the width. So if we call the area height times width, and I know that the height is 3 times the width, then I can put 3 width in place of h. And my area will just end up being 3 width squared. And the width is the distance of that little strip I drew, which is top minus bottom because we're going vertically. And then I need my x boundaries, which are 0 and however 2. Okay?
I was thinking why I was trying to solve it in terms of why. When I was looking at it.
Gotcha. So you're like side first.
I didn't even try. I looked at it, I was like, I don't know. So I just
Alright, let's look at number 12. This comes up now and then. We haven't seen one yet. There's no kind of graph that makes? I like how you gave the answer, but like didn't really. I don't understand what you said. Makes a circle. X squared. So the formula for a circle is x squared plus y squared equals r squared. That's a circle centered at the origin, and the radius of that one's 10 because that represents like the r squared. So they want to know that's going to create. It'll look like this. So that's 10. That's 10. That's negative 10. That's negative 10, and we're looking for each cross section perpendicular to the x-axis. going this way are squares. Okay. So we're gonna have squares coming out. So if that's W also. So our area is gonna just equal W squared. Agree so far? The issue is it looks like there's only really one equation, but this is what I want to show you. There's actually two. They're asking us to go perpendicular to the x-axis, so we want to be in terms of x, which means we want to solve for which variable? Solve for y. You just take a drink before I ask a question every time.
Well, no, I was using my crack to apply.
Oh yeah, the minor, not the UHY. Okay. So I'm going to solve that for y. So I would subtract x squared from both sides, and then square root it, and this is where you'll get two equations. Because if I'm solving something with a square, there's two answers. There's the positive and the negative version. And how that works is this part up here is the positive, and this part down here is where y values are negative, right? So that's the negative. So see if you can set up the integral. I kind of started a lot of it, but see if you can set up the integral after that. Pi squared. Or go ahead, never mind. I think you should get the same answer.
That would only be if it was a semicircle.
Oh, right. You don't even have to do the two thing that you did. So x values go from negative 10 to 10. I'm looking at these values because those are the x ones. Area of a square is the width squared, and then times the x, and the width is always top minus bottom. So it's the square root of 100 minus x squared minus negative square root of 100 minus x squared. And if you want to get fancy and tell me that's negative, so yeah, I wouldn't do this, but on the multiple choice, they would probably say, give you this as an answer. So actually, they'd probably give you, might give you this. But those are all correct, they're all fine. Right? Alright.
How did the two get split outside of the?
No, because like if I do, say this is a minus negative a, that's 2a, and that's all inside the square root. Right? Okay, so I just wanted to show you that one. Because the circle thing is a little bit different. Let's go to 8, next one. So like a side quest before that, see, we are going to work with equilateral triangles. Find the area of that shape coming out of, like that's a cross section. If I tell you that's x, can you tell me the area of that triangle? Right now, don't say it, don't ruin it. But see if you can tell me the area of that triangle. It's equilateral. use trig or special right triangles if you remember those. That Pythagorean theorem, if you want to get it. It would be harder, but it might work.
It's the same.
Just a lot. I think that's harder, but maybe not. Somebody has like zero idea where to start. That's fine if you do. I'm just wondering, like, is this valuable or not? Maybe for them. See if that helps. Maybe it does, maybe not. Everybody think they got it? Yes. What do you think they got?
X over 2 times 3 square root of x over 2.
You mean square root of 3.
Oh, yeah, sorry.
Yeah, then you got it. So, if that's x, right? So what's this? X over 2. I don't know if you remember your 30, 60, 90s, but if that's x, actually, it was usually like this. The short guy's x, that's 2x, and then that's x times the square root of 3. That's a 30, 60, 90. So if that's, we're just doing that divided by 2, basically. If that's x, the way you get from here to here is cut in half. The way you get from here to here is multiplied by root 3. So this is x over 2 times root 3. And then the area of a triangle is 1/2 base times height, right? So what's the base of this triangle? The big triangle. X. And the height is x over 2 times root 3. If you multiply that all together, what you get is the square root of 3 over 4 times x squared. You need to know that formula. Whether it's like, oh, I can just figure it out because I can understand like 36, 90 stuff, or whether you memorize it. There's going to be questions that ask for the area of an equilateral triangle. So you got to either know how to get to it or. Like, do you want me to, or are you asking if it's possible? Okay. So it'd be x over 2 squared plus, I call that. Yeah, like h is fine. Equals x squared. So x squared over 4 plus h equals x squared. So h equals 3/4 x squared. Right? Because I would subtract 1/4 of those.
It would be h squared.
So then h is the square root of 3/4 times x, which is the square root of 3 over 2 times x, which is what we got. And then you do like the same.
Root square root of 3 over 4.
Because that's just the height. The area. Okay, so let's apply that to the problem we're working on. So the actual lesson itself is the exact same as yesterday. The only like really thing that's I think going to be challenging is that formula. Or I shouldn't say challenging. More challenging than yesterday. So this is what I gave you guys yesterday, and then you just got to plug the area formula in. So like yesterday we did rectangles and squares. Rectangle. I was going to say that, but then a square. So that's you just plug it in the area formula, and then they're just giving you like, hey, we might ask you to find these also. So equilateral triangle. I'm just gonna write down the area formula. Area equals the square root of 3 over 4 times x squared. Isosceles right triangle. Isosceles means the base and the height are the same. So if I go to do 1/2 base times height, but the base and the height are the same, couldn't I call that 1/2 times base squared? The base and the height are the same thing in an isosceles right triangle. So the area of an isosceles right triangle is 1/2 times the base squared. Or just think about it like b squared would be a square, right? And then 1/2 of a square is an isosceles right triangle. Semicircles. So the area of a circle is pi r squared, but you only want half of it, so it'll be 1/2 pi r squared. But like beyond that, it's the exact same stuff. You would plug in, top minus bottom here, or right minus left if you're doing it in terms of y. Put top minus bottom in there, top minus bottom in there. So the problems are the same. So we're working with this one up here, x squared and square root of x. Let's go through these three, one of each, and then let you guys go. So the volume is the integral of the area. Just to rewrite what we have there. This is 1 comma 1. This is y equals root x. And that is y equals x squared. We are perpendicular to the x-axis, so we want to be in terms of x, and we are. Left and right boundaries, the x values of those are 0 and 1. The area of an equilateral triangle is the square root of 3 over 4 times the side squared. And the side is the distance of our representative strip. So perpendicular to the x-axis is this. And then it's like, okay, how long is that strip? That's the top minus the bottom, so root x minus x squared. So it's same stuff, right? Question on it? So b, they're super similar. They're still going to be from 0 to 1. But now your formula is 1/2 times the side squared. It's 1/2 base times height, which is 1/2 base times base. So 1/2 base squared. And the base is just top minus bottom, the same distance that went in the other formula. And then semicircle, still 0 to 1. Now the area is pi times r squared. And the radius is the distance of the representative strip. So you'd have like, oh yeah, good call. I do have to do that. Why do I have to do that? This distance is the diameter. Maybe it wasn't clear how they're coming out. But that distance is going to be the diameter. So you want to divide that diameter by 2. So root x minus x squared. That's my diameter. Divide that by 2 to get the radius, and then square. And it's a semicircle, so we put a half on the outside. You will often see these as, this kind of messes people up. They'll sometimes write it like this on the multiple choice, and you'll feel like you got it wrong, but you didn't. So that's actually the same thing. So where the 8 comes from is that 2 is on the bottom and squared. So it's really 4 on the bottom, and then there's 2 on the bottom here, and they're combining those. Yeah. This 2 here. So let me try to do this. So we got something like that. This distance is going to be the base of a semicircle. So your semicircle is going to kind of come out at you like that. But if this distance is the base, that's like all the way across the semicircle. So it's the diameter. But we want to know the radius, so that's just the half, like half of the diameter. That's all I'm doing. I'm saying you gave me diameter. I need the radius, so I'm cutting it in half, and then it's pi r squared. All right. Is that your first question? You can write the 1/2 in the. You can write it here. You can put it here. You can't put it inside at all because then it'd be square. Like this 2 is inside because that's diameter of the radius. But the half circle that can't go inside the square. But it can go inside the inner. You could just easily put it like pi over 2. Other question? If you want. Yeah. The bottom one, yeah. No worries. You're just gonna like rubber one it. Go ahead and get going. That's all I got. See what numbers we're doing. So you can do the entire thing, but you're just setting up, not real solving. I mean, you might want to solve like 1 or 2 just to like convince yourself that when you eventually need to solve it, you can. It's just plugging the calculator. So as long as you're comfortable with that. So you do the whole thing, 1 through 12, but just set them up. That to yourself.